Yep. All right, 1 minute, starting now. We got time. Caleb, are you able to get on? Okay, well, good. There's Becerra. Those that are in, let's get it. I mean, if you're on the internet at all, you should be able to get on this call. Thank you, Keaton, for your answer. Thank you, Keaton. Thank you, Monis, for yours. So, Caleb, if you're on, go ahead and give me your answer. Abuelito, are you on? Let's go. Try it again. Disconnect and connect. You can't get ClassLink? Go directly to Schoology. Have you bookmarked it yet? If not, you guys are gonna have to do all this by the recording, and you don't want to do that. I mean, you can, but I'd rather be in line. All right, thank you, Chastity. We've got 15 seconds. Randy, are you in class? All right, let's waiting for yours. Nada? Yeah, do the best you can. If you need to look on behind somebody, you can look on behind somebody as well. Thank you, Ashmeet. Thank you, Turner. Good. Okay, you guys did great on that, by the way. Excellent job. No kidding. Like, I'm really impressed with how well you guys remembered that. That really this is just a bit of knowledge, but it kind of leads into what we were doing today. So I'm going to kind of draw this out on a graph really quick. So let's say this is going to be number of individuals. There's number of individuals, and this on this x-axis, this is going to be pH. So let's say this is a pH of 5, 6, 7, 8, 9, and this will be this line represents the original population. So let's put that on here. Let's say this. Let's let this person in. Abuelito got in. This is the original population, and then this is going to be our new population. The new population. So it says that they are increasing. Hello? Abuelito.
Oh, yeah.
Can you mute it? You're on your phone. Good job. The new population, because they are becoming more tolerant, it says that acid tolerance is significantly increased. We have anything below a 7 is an acid. Anything above a 7 is a base. So this is if this was the optimum for the species prior to the Industrial Revolution, let me let these kids in. I got some people in the waiting room. And it shifted in this case, it shifted in this case to the left to a lower pH. So where we had an optimum, say 7.25, now the optimum pH for this population is close to a 6. And we have a curve here. And this curve, and knowing what this curve is going to be important to what we're going to be doing today. So just as a heads up, everybody's going to be using your computer today. I am not going to be talking very much. We're going to watch a couple of videos, and then we're going to get pretty busy. You guys are going to spend a lot of time in class working today. Some important dates that are coming up. We've got 2 summatives that are going to be here within 2 weeks. Don't forget summatives. I've seen a ton of you guys in the past week, and I'm really happy to see it. I get these little Google alerts. I can see you're in there amending your documents. So good job on amending those documents. You're still going to want to copy and paste whatever changes you make into, you'll see the new link. I have a new link for your submissions. For your new submissions, you'll use a new document, and I'll give you a fresh round of feedback. So whatever you're practicing on, where I've given you comments, you'll see I can take that document and you can change and drop it into the new doc that I have provided, and it's in the same folder. We also will have the evolution exam on the 18th of May. And then I do not know the final, what day they're going to set for the final exams. That's going to be up to Mr. Rather, and he has not given me a date for that yet. He did say that he will be giving us 2-hour blocks. And so you won't run out of time or anything like that. And remember, the final exams are final. There are no retakes on this. So you want to start studying now. You've got all the videos. If you go to my YouTube channel, you can literally start at the beginning of the year and kind of work your way through. Maybe when you're walking or you're doing something at home, you could just kind of take a refresher listen to the videos. Okay, well, this is what we did last time. I just want you guys to remember what this is that we were doing. We were looking at an experiment. We were selecting traits with the greatest trichome density. And then we had these are just 5 of many different constants that you guys came up with. And we had 2 dependent variables. What we're going to do today is we're going to analyze this. We're going to analyze it against the control. And I'll show you how we're going to do that. But before we do that, I got something we need to think about. Now that we know what we're measuring, and we're measuring here the density of trichomes and gene linkage. Now that we know this, how can we analyze it? So what we're going to use, and I know I showed this to you guys earlier in the year, like way back in October, want to revisit this because you're going to see this on your test as well. Standard deviation and standard error. I'm also going to show you guys the tidy method. We've shown you before, I want to show you again, and then we're going to use Data Classroom to do this. But before we get started, I just want to refresh us over what standard deviation and standard error are. Okay, I'm going to go back to it. So I'm going to the website. I'm going to open standard deviation first because standard deviation.
Sometimes you need to get away from the kids for grown-up time, or get away from the grown-ups for kid time, and just get away from home. Verbo.
Hi, it's Mr. Anderson, and in this video I'm going to talk about standard deviation. When you're collecting data in a science lab, the amount of data you collect is important. So is the average, but another important statistic is going to be the standard deviation of your sample. And so in this video I'm going to show you what it is conceptually. I'm then going to show you how to calculate standard deviation by hand, and then finally I'm going to show you how to calculate it using a spreadsheet. And so first of all, what is it? Well, to understand standard deviation, you have to understand the normal distribution. And so what does that mean? Well, it's a bell-shaped curve. You might think of it like that. And so in the United States, most men are about 5'9". In other words, that's the average right here. That's the mean, or in statistics, that's the X bar. But there's going to be a lot of men who obviously are taller than that, and a lot who are shorter than that. And so the standard deviation is going to measure the spread or the variation in this bell-shaped curve. And so basically, if we were to go right over to here, this dark area is going to be 1 standard deviation above and 1 standard deviation below the mean, or it's going to be below the average. And there's something cool about that. About 68% of the individuals are going to be in this area. So 1 standard deviation above and below. If we were to look at this, for example, down here is 2 standard deviations. And so 95% of individuals are going to be within 2 standard deviations from that mean. And then finally, if we go way down here, 99% of individuals are going to be within 3 standard deviations of the mean. But the standard deviation is going to vary depending on the data that you collect. And so if we had 2 curves like this, so if this is 1 curve, and then we had another curve that looked like this, that data plotted on the same curve, this one is going to have a smaller standard deviation than this one. They're both going to have standard deviations, obviously. They're going to have amounts where it's 68, 95, and 99% of the people. But this one down here, since it's more spread out, is going to have a higher standard deviation. And so how do we calculate that? Well, the equation is a little scary. The scary part, it ends up being right here. So students are a little scared by that, the summation symbol. But it's actually pretty straightforward. It's not that hard to calculate the standard deviation. And so let me show you how to do that. And so first thing you want to do is you want to have a data set. So here's going to be our data set right here. And to make this easy, let's say we just have 4 pieces of data, 1, 2, 3, 4, and 5. So you're collecting data, and this is the data in your data table. And you want to figure out the standard deviation of that. Well, to set that up, we're basically going to take the square root of the summation of this divided by the degrees of freedom. So that sounds a little bit scary. And so let's go to the scariest part to begin with. So let's look at what's going on right here underneath that square root. And so what this is, so if we go like this, the summation of x minus x bar squared basically means for each of these data points that I have, we're going to have to figure out what's right here. So x minus x bar. And so the first thing we have to do is figure out what the average is. We have to figure out what x bar is. Well, basically, if I add 1, 2, 3, 4, 5 together, I get 15. And if I divide that by n, which is the total number of data points, so in this case, n equals 5. So we have 5 data points over here. So if I divide 15 by 5, hopefully you can figure out an average. The average is going to be 3. And so the mean is 3, or the average is 3. So what we have to do is we have to calculate this value for all 5 of these data points. What does that mean? Well, right here we're going to use x, and x for the first case is going to be 1, so that's going to be 1 minus 3, and then we're going to square that. So what is that? 1 minus 3, and we square that is going to be negative 2, and if we square that, so that's negative 2 squared, and if we square that, that's 4. Let's go to the next one. Well, this is 2 minus 3, so that stays the same. So that's negative 1 squared, and so that's going to be negative 1 squared, or that's going to equal 1. If we go to the next one, that's easy. That's 3 minus 3 squared equals 0, and if we square 0, that's going to be 0. Go to the next one, that's going to be 4 minus 3. And so that's going to be 1 squared, or equal to 1. And then finally, if we go 5 minus 3, square it, that's going to be 2 squared, and that's going to equal 4. And so if you ever see the summation sign, don't be scared by that. It's not scary at all. It just means you got to do a lot of work. So for each of these data points, 1 through 5, I had to calculate what was in there. And then I have to add it all up. So I have to add 4 plus 1 plus 1 plus 4, and if I add all those up, I get 10. And so what's going to be inside there? It's simply going to be 10. So let's figure out the rest of my standard deviation. Standard deviation is going to be the square root. In this case, we solve this as equal to 10, and then we're going to divide that by n minus 1. So what's n? That's our sample size. In this case, it's 5, and so we take n minus 1, and that's going to equal 4. And so what is our standard deviation? It's the square root of 10 divided by 4, which is 2.5. Or if we take the standard deviation of the square root of 2.5, that's going to be something like 1.58. And so you're going to have to use a calculator to figure that out. Well, what does that mean? If we were to plot this data as a histogram, for example, this would be our standard deviation, 1.58. And so it takes a while to figure that out based on doing it by hand. And so if you want to, give it a try. And so here's data set over here. And so try to calculate the standard deviation using this data set over here and try to do it by hand. I'll put the answer down in the description below the video, but I would give it a try. It's worth doing once on your own. And again, this is going to be our formula.
Okay, so I'm going to pause here for a moment. We're not going to be doing this by hand. I really want you to guys have a very good conceptual idea. Again, we're talking about having a distribution. So in some of your guys' experiments, you're going to have a distribution of data. And I want to try to explain to you again what a distribution is. So a distribution of data, let's say I have, I've got some sizes. Say you guys are measuring plant growth, right? So let's say you're measuring plant growth. And their growth is, and we'll say growth is in centimeters, and you've got anywhere from between 10 to 1. You're probably going to have a distribution of that data. There's going to be few that are going to be 10. There's going to be a small group that are going to be small. And then somewhere here in the middle, this is your X bar, this is your mean. This is the average of all that data. So I want you to have different ways to analyze this, because the thing about means or averages really mean nothing when we're measuring two groups. This could be your experimental group, right? But you also will have a control group. Well, if you have a control group and the mean is the same, but the distribution is different, well, so what if you have the same mean? The mean really doesn't mean anything. How are these distributions going to be different? And that can make a big difference. Now, if you get the same average, that's kind of cool. Actually, there probably won't be a statistical difference, but you could talk about how the distribution was different. And we'll see in a moment what that's like. Now, what you guys are going to do today is you're going to be using Excel. You're going to be using spreadsheets. And we're going to do that in just a minute. And I'm going to show you how, but he's going to show you, and then I'm going to show you, and then you guys are going to do it together. So let me clear all these drawings, get this crap out of the way.
Standard deviation. And so try to do that by hand. And so I'll wait. No, I won't wait for you to do that. Pause the video, try to do this one, and I'm going to show you how to calculate this really, really quickly. And so I'm going to show you the spreadsheet shortcut. And so how do you do that in a spreadsheet? It's pretty simple. So what I'm going to do is going to take this data and I'm going to switch over here to Excel. So here's the data right here, 0, 2, 4, 5, and 7. And so I've entered my data into different cells, and now I'm going to figure out the mean, just to show you how easy this is. To figure out the mean, I'm going to hit it equals here, and then I'm just going to start typing. So I'm going to type in average, because the spreadsheet's not going to use the word mean. So I type in average, and then I select my data. I hit a close parentheses, I hit end, and it's going to give me my average, which is going to be 3.6. So if I wanted to know the average, there it is.
And watch how he does this. He'll put in equals, the formula, and notice the parentheses. You have to use your parentheses or it will not work. So this is an important step for you guys at home.
If I wanted to know the median, for example, I could just type median, and I could go down like that. And so spreadsheets are super simple. And so what are we looking for? We're looking for the standard deviation.
Okay, I've got a question. Let me see what the question is. I'll make sure I get that. Yeah, I'm going to show you exactly how to do that. I'm going to show it. He's going to show it again right now, and then I'm going to show you guys when I do it as well. So you'll have another chance to see how I do it. It's easy.
So how do I do that? I just hit equals. I then start typing STDEV. Can you see how it pops up right here? Standard deviation. Parentheses. Then I'm going to select that. And then I'm going to go like that. So what's the standard deviation? It's 2.7. What does that mean? We had a bigger spread in the second data set than we did in the first set, a higher standard deviation. And if you did it by hand, it should have looked something like that. So that's standard deviation, and I hope that's helpful.
So we're going to do this in steps. I'm going to stop sharing. I'm going to go to today's lesson. Excuse me for a moment while I get there. So I want you to see where I'm going to be getting this data. Here we are. So we're going to be using Artificial Selection Lab. This is the copy of it. This is the Tricone data. So I'm going to open this. I think I'm going to open it. Let's see if I can get this sucker to open. Is it opening, Daniel? Yeah. Okay, perfect. So we've got several things to use here, and I'm going to show you how we're going to do it. We have several different pieces of data the kids collected. Remember, they wanted to see how trichome density was going, if it was going to increase, and they also wanted to see how trichome, if these cotyledons and stomates were linked. So I'll measure the P generation first. So they've got it out to the side. This is how they set it up. And I sort of like how they set it up, and I sort of don't. I think it's good for maybe putting this as how you would put it into your IA, like a really neat little way, because you've got your P generation, you got your F1, your F2. It's a good data table for just having a data table in your paper, but it's not really good for analyzing. But you can still do it a little bit with Excel. So let's just analyze the mean of all three: cotyledon, trichomes, and stomates. Let's just analyze the mean really quick. So mean is average. So I'm going to type in average. Usually it comes up right off the bat. You can see average. Let's see. average right here. Now you'll see that parentheses, see that it's already got one side of the parentheses, and I'm using Colodon, so I want to go over here. And all I got to do is just highlight my data. It encapsulates it. I got cell B4, so here's B, cell B4 down to B13. It's in there, and then I just hit Shift to call, and then the O, which is your parentheses. Close it, enter. And it gives me my average. I don't have to sit around and calculate this, but with a calculator, I just did it in Excel. It's super nice. Now let's look at standard deviation for Colodon. It's easy. Hit equals, and then let's do standard deviation. You can see it right here, standard deviation. This mine comes up as deviation.s. So I'll click this. I'll highlight the same set of data. And parentheses, enter. Standard deviation was 0.648. I really don't like, may format this. I like doing it in Excel. I may want to reduce the number of, let me see if it'll let me reduce this. No, it says, no, it's actually 4.6. I need to expand that. I usually use Excel. Let's decrease my decimal size. Let's highlight this. I don't want that many decimals. So we'll just round to the nearest 10. There we go. 4.6. Nice. Easy breezy. That's really step one. Would you guys like me to do it with the F1 generation before you guys get a chance to see? Because we're going to jump over to standard error next, and then I'm going to let you guys work. Would you like me to see me do it here with the F1s? Okay, all right, cool. Let's do it with the F1s. I'm just going to do Colodon. I'm going to leave you guys with Trichome. You guys will do it with Trichomes. I'm just going to do Colodon. And I want to see, should it change? These are under selection. So, right, we're selecting for Trichome. If they're linked, Colodon should change with Trichomes, if Trichomes change. So let's go to Colodon, see if the mean is any different. Equals. I highlight my data set. And, oh, so did something wrong. I don't know what I did. I wasn't paying attention. Hold on. Let me go try it again. Equals average. That was what I did. Somebody told me I did not put the average. There's average. Thank you for telling me that. 15.5 again. Wow. So they didn't change. Let's see if standard deviation changed. That's possible that standard deviation changed. There's standard deviation here. It's even saying it thinks I want B18. I don't want B18, so I'm going to go ahead and ignore that. Standard deviation S. And I want this set of data right here. And it's 4.6 again. It did not change. I'm going to reduce my decimal signs. Did not change. So I suspect that these probably did not, these aren't linked. Probably not. Let's see what questions you guys have. Yeah, average. Yeah, you saw it. Thank you, Turner. There was a couple people saw me. Okay, so let's go to the next video because we want to know how to use standard error. That's the last thing. And that one we actually have to do a simple little calculation by hand. And this is great if you're going to retake the ACT. They're going to reference this in graphs too. So it's important that we understand how this works as well. So I'm going to stop sharing. I'm going to go back to our lesson today for testing selection so that you know if you want to come back and reference these. Here's standard deviation video, here's standard error. Let's watch this.
For those of you that aren't familiar with Grammarly, it's a writing assistant that you can easily download as an extension. So
Hi, it's Mr. Anderson, and in this video, I'm going to talk about standard error. Standard error is one of my favorite statistics, and the reason why is that it shows you how good your data is. And let me show you what I'm talking about. So let's say I collect two data sets. So this is data set 1, and this is data set
So Diego, which data set do you think is more reliable? Data set 1 or data set 2? Which data set would you say is more reliable? Data set 1 or data set 1? Yeah, exactly. It's more reliable because you have a greater sample size. Sample size matters. So like you guys that are talking about in your eyes that you've got a sample size of 3 or 4, no dice. We're not doing 3 trials. I recommended, how many trials am I recommending you guys run? Drop it in the chat. Ooh, thank you, Turner. Can you put that out for everybody? You are on target. You are on fire. Can you put that out for everyone? Thank you. Everybody should have at least 20. The more data you have, the more reliable the data you have, the more reliable your data is, the better your answer is, the better your answer is, the more confident you are that you know what's happening. You don't know if something's, you don't know if there's a trend if there's only 1 or 2 points of data. That's it. So
if you were to look at the data, you would say, well, this one over here seems to show more precision. It's going to have more data, and it doesn't seem to be spread out as much. But if I were to graph this data, so of these 2 data sets, if I were simply to create a graph showing the mean or the average of the data, both of them would be 12. And so if I had a bar graph, it would look like this for both data set 1 and data set 2. And so you should never have a bar graph if you're using it to represent a lot of data, unless it has error bars on it. And so how do you figure out what the standard error is? How do you make these standard error bars? Well, let me show you. So basically, I'll work through data set 2, and then I'll ask you to work through data set 1. I'll put the answer down in the description down below. And so to figure out standard error, the equation is really ingenious. Basically, all they do is they take the standard deviation and we divide it by the square root of the sample size. Why is that important? Well, what does standard deviation measure? Standard deviation is going to measure the spread, or how far the data is spread out. And so if you have a lot of spread, then you're going to have a large standard error. And the other thing it uses is the sample size. So the sample size is how much data are you collecting. If you collect a lot of data, and we're going to have a large number here, then that's going to decrease my standard error. Likewise, if I have not much data at all, that's going to increase my standard error. So let's get to standard deviation. If you don't know how to calculate standard deviation, or even what it is and how it measures spread, you're going to want to go watch a video. And so here's a little link I'll put to a video I made on standard deviation. So you could simply click here, or I'll put a link to the standard deviation in the video description down below. But you want to figure out how to do standard deviation. I show you how to do it by hand, and then I'll show you how to use a spreadsheet to calculate standard deviation very, very quickly. And then what is sample size? Well, sample size is going to be the number of trials that you do, or the number of data points that you collect. And so if we were to look at data set 2, there are 10 numbers over here. And so that means I'm going to have a sample size of 10. And so keeping those in mind, let me switch over to the spreadsheet and show you how I would figure this out. So right here I'm in Excel. This is going to be data set 2. Again, I'm going to show you how to do that one, and then here's data set 1. So what I'm going to do is, since I've got this column right here, I'm going to first of all calculate the average of that, or the mean of that. If you were to type equals MEAN for the mean, nothing will show up. And that's because spreadsheets don't use the word mean. They're going to use the word average. So you can see that that pops up. I'm going to put first I hit an equal sign, then I'm going to write in average and then parentheses. And now I'm going to tell Excel which kind of data I want to figure out the average from. I put it in parentheses, and it simply calculates for me that it's 12. Now here's a quick little trick. So I've done the average for this column. If I select this average and then I move my cursor down here, watch how it changes. So it changes from that to that. And so I can click it now and then just drag that over here. And Excel is smart enough that it's going to figure out, oh, if you want the average of this, now you want the average of this column. So you can see that the average is going to be the same. Now let me show you how to do the standard deviation. If you did that by hand, it takes forever. And so it's really important that you use either a calculator or a spreadsheet to do this. I'm going to hit equals, and then I'm going to start typing STDEV. That's going to be standard deviation. I'm going to hit a parentheses, then I'm going to select the data, and then I'm going to hit an end parentheses, and there's my standard deviation. Now, if we were to...
All right, do you guys think the standard deviation is going to be higher or lower for data set 1? higher or lower? Drop it in the chat. Should it be higher or lower? Thank you, Turner. God, you're on fire, Turner. Thank you, Monis. Thank you, Santos. Oh, yeah. Okay. Love you.
Compare that to the standard deviation of data set 1. So again, let me do that trick. I'm going to select this, move this over here. You can see the data set 1 has a much larger standard deviation. That means it's going to have a greater spread in the data. But I'm going to figure out the standard error of this first one. So this is 0.825. And so I'm going to remember these numbers here and then switch back and figure it out. So let me write down the things that I need to know. So my X bar, or my mean, I said, is going to be 12. The N, or the sample size, we said is going to be 10 in data set 2, because I have 10 values over here on the right. And then the standard deviation that I just calculated is going to be 0.826. And I did that in Excel. So how do I figure out the standard error? So the standard error of the mean is simply going to be the standard deviation, which is 0.826. And then I'm going to divide that by the square root of the sample size. And the square root of the sample size is going to be 10. And so this is equal to 0.826 divided by the square root of 10. I'm going to need my calculator right here. And that is going to be 3.6. And then I have to figure out, so let me write that down. So that's 3.16. And then if I take 0.826 divided by 3.16, I get 0.261. So 0.261 is my standard error, or standard error of the mean. So you could figure out the standard error of the data set 1. Remember, in data set 1, we simply had two values, 9 and 15. And so if you want to figure out the standard error of those, and so you make sure you're doing that right, you could do that, and I'll put the values down below. But what does this all mean? Well, let me show you why this is super important. So if we go over here and look at our graph again, so I just figured out the standard error of data set 2. And so what that means is data set 2, my mean is 12, and so the average is 12. But I could add an error bar on the top, like that. And then I could add an error on the bottom. And my standard error is going to be, we said, 0.261. In other words, it goes from 12 up to 12.261, and then from 12 down to 12 minus 0.261. So we're going to have an error bar on each side. What you could do is go figure out set 1. Set 1, you're going to have a much larger standard deviation. You're going to have a smaller sample size. And so I would imagine you're going to have pretty big error bars. And so what's neat about that is the bar graph.
All right, so let's get to work back on that spreadsheet. I'm going to call on one of you guys to help me out. You need your phone for a calculator. We're going to use a calculator here. So I've already figured out a couple of things. I've already figured out this mean and standard deviation for cotyledons. So for standard error, there's no formula for it. So I need to make a calculation. So let's remember our formula again. So our formula is, oh, you can't see this. Somebody says, oh, you're not sharing your screen. Oh, I guess it would be better if I shared my screen, right? You guys. Okay. So let me write the formula here. Annotate. All right, so I got standard error of the mean equals standard deviation by the square root of n. So n is my sample size. So we have some information here. So we also have standard deviation. So standard deviation is 4.6. How many points of data do I have in here? How many points? Oh, we're doing cotyledons. How many points of data? What's our group size? What's our group size? Abelito, what's our group size? Thank you, Turner. You're always the first to answer. You are dialed in. I thank you, George. Letting Abelito see. I got Abelito. How big is our sample size? How big is our group of data? What's n equal to in this case? What is n? How big is this sample size? How many plants do they have in every trial? Thank you, Monis. Thank you, Gavin. You just count them. 1, 2. Okay, we're trying to find n. So n here, n equals sample size, essentially. So how many plants did they measure for this? How many are in this group? So I've got 1, just count them with me. Let's count them with me. You can, no, you count. I'm gonna put a little tally mark. It's 10, that's right, it's 10. So what's the square root of 10 in that case? What is the square root of 10? Ali, what is the square root of 10? Thank you, Johnson. Thank you, Weiss. Thank you. Makes me feel so much better that you're learning this. This is really is important. Remember, data, what's up? I'm sorry? Square root of 10, yeah. 3.16, that's right. So I've got 4.6 minus by 3.16. So let's see, what is that number, Diego? 4.6 divided by 3.16, what's that number? I'll type it in here. 4 point, it's right there on there. 4.6 divided by 3.16. What is that number? Thank you guys. I appreciate it. Thank you, Diana. Thank you, Manas. One point four what? 1.5, 1.45. Okay, so I'll just round up and say 1 point. Well, let's just get 1.4.5. So I'm going to round up and say 1.5. All right, so let's get this on here. So 1, and you would just simply type in here 1.5 and done. That's it. You guys did it. Now what I'm going to do is I'm going to have you guys finish all this. And what you're going to have to do, I'm going to put you in breakouts. And let me stop sharing or going back to the website. Let me see what you're seeing here. All right, so when I put you in breakouts, I want you guys to share your screen, talk your way through one person, and we're going to do this in stages. Let one person do it. Everybody's going to submit this today. So this is an assignment, and everyone is going to open and do this on their own. But I want you guys to see one person, whoever feels the most confident in doing this. You're not going to be the person that's going to do this. You're going to help somebody else that feels least confident. So you need to take a risk when you get in your group and go, I feel least confident in doing this. I'll make it where you can edit it, Monis, in a second. I had it where you couldn't edit it, but now I'm going to make it to where you can in a second. Whoever feels least confident, I want the other people to walk them through it. So you share your screen. It shouldn't, I've already analyzed some of the data for you. You'll see whenever you get in there that some of it is already analyzed for you because I just did it. I just amended that document. And then you guys are going to amend it, do it for the rest of the groups. Questions before I put you in breakouts? Are there questions before I put you in breakouts? I'm going to go here and I'm going to give you guys editing access. Anybody? Yeah, if you have an Uplift account, you'll be able to do it. Yeah, it's in today's folder. It's right here. You can see it. It says Tricone data. It's called Tricone data. Let me go back down. We are right here today. Testing selection, and it says Tricone data. So you should be able to find this. Are there any other questions? You do have to be logged into your Uplift account. And yes, I will count it as a grade. If you get it all correct, you get a 100. It will be considered a scholarly habit grade, just like the grade for asynchronous if you did that. So if you didn't do the asynchronous work, well, this will be your chance to try to bring up that category. All right, I'm going to put you guys in breakout rooms. I don't have any other questions. I'm going to put you in relatively smaller breakout rooms so that you guys have more people to lean on when
Pope.
you get in there. Yes, sir.
So when you do standard deviation, it says normal standard deviation pops up and then standard deviation
Yeah.
pops up. Which one do you do, or
Use
does it
the-
matter?
If you use Excel, it'll just be normal standard deviation. You use S.
Okay.
All right, you guys, any other questions? All right, Deb, you're there and I can hear you well. Who is going to be the person that's going to share their screen and go through this first? I'm sorry? Not yet. I'm just asking who is going to be the person that's going to do this first in that breakout room. I was asking, who is that person going to be? Dev, who is the person?
I guess I can share my screen.
No, the person that is least comfortable.
Oh,
I want
least?
somebody-
I don't know.
Yeah,
I'm not
so
sure.
if somebody in your group, you guys need to say, hey, who feels least confident? And the rest of you guys walk them through this. Help each other. You get better by helping. And if you feel really confident in doing this, then be the one that helps. Be the teacher, because you don't understand anything until you can really teach it, right? So I want you guys to be leaders in the class, and some people be led, and don't be uncomfortable if you're being led. That just means that everybody's growing together. All right, here you go. I'm going to put you guys in there. It should not take you longer than 10 minutes. I'm going to bring you back. You got 10 minutes. Analyze that data and submit. Go for it. So if you're not able to get on, you're going to have to be leading. Are you on the call? I'm sorry? You keep getting in this. Are you getting disconnected through on your phone? Let's go. I'll let you back in. You keep getting disconnected, but you haven't dropped out of the call yet for me to let you in. All right, I'll let you in. All right, I'm going to let you in. I'm going to have to put you in a room. You better start talking to your group.
Huh? Okay. What are you talking about? I ain't spoken.
You're not going to be the person that's going to be able to do it.
I went to the restroom while Mr. Pope was away. I don't know who was going on. Even though I'm the person. You stole these. Dude,
Yeah. What's the name of the document?
Minus.
Did you hear you talking? Tell me. Talk to it. You gotta take 10 minutes. You just take a step, an extra step.
Oh, yeah, you better look at your phone. Standard deviation? My God. I'm gonna go to that one.
Who's sharing the screen?
I'm the third year. I was in a restaurant. Okay, you should have had that problem.
Dude, you're way off topic. You don't have time to fool around. For which formula? Can they hear you? Yeah. What's the question? What are you saying the screen is? What are you talking about? If the person was sharing the screen, you probably would see it. There we go. Okay, so yeah, so it's gonna be equals, just type in there equals. The first one's gonna be mean, you gotta do mean first. So you're doing trichomes. You're working on trichomes now. There you go. Equals. And then average.
A lo mejor me llegó, pero sí lo mandé.
You did, you're looking on me.
A ver,
And
tú,
then you're gonna
¿verdad?
highlight that column, yeah. You guys help me.
Yeah, for silicon, I think it's 14.6. And then for the SCED, it's 4.6. ¿Ya lo pusieron?
You did?
Yeah, 14.6 and then 4.6.
Oh.
No, it isn't the same
¿Ya ves cómo se llama?
Okay, but you didn't say it.
What?
Earlier should have said it.
Ah, bueno,
Down the
bueno,
line.
no creo, no. Como dijiste tú. No.
Yeah. The width of the largest.
Oh, how do you spell it? Trichomes?
Trichomes, yeah, trichomes.
The number I think is 4.6. For the first one.
We don't have nothing.
Yeah.
We don't have nothing down for typo. We only have for the second.
Yeah, I mean, you got that help you.
When you get the bottom, don't you have to divide them?
What?
Don't you have to divide,
For which one? For what calculation?
for the trichome?
You said 1.95.
You'd say it calculates at 40. So what are you trying to, what value are you trying to get?
I'm trying to get this.
Standard error?
Yeah.
There's a formula for you. Did you write it down? Take notes to the lesson? There's a formula for standard error.
Yeah. Never mind.
If somebody needs to go back, you just say, no. If you need help, you call me in there for that.
Okay, now divide that by.
What group are you in?
Room 5.
1.9 divided by 3.
Who can't? Because she's not logged into Google. She's logged in with her Uplift Google account. She can. Okay, so you guys are trying to figure out the formula for standard error. Is that what you guys needed? Yes, no, maybe so.
Yeah, so I know that it's gonna be 10 for all of them, but how do we, just basically just a formula for it.
Okay, so I thought I could annotate in here, but I can't. So only thing I can do is put it in the chat. It's going to be standard error, whatever standard error is. Standard deviation, whatever that is, divided by the square root of n. That's really the formula written out in words. So let's go back and look at the one that you're working with. You've got standard deviation is 2.5. Let's just say 2.6. Just go ahead and reduce that number. You can, if you can look over, see at the top, kind of under format where it says there's a decimal and an arrow going backwards. No, under format. Nope. Under format. There's an arrow. There's a dot 0. There you go. Go ahead and just reduce that. There you go, 2.6. So it's going to be 2.6 divided by the square root of 10. The 10 is your sample size. So whatever that number is, you have to use a calculator to do it. I'm going to use it right now. So let me see, square root. It's going to be 2.6. Okay, I got it. So first thing you got to do is, what's your sample size? How many plants were in this sample?
10.
10. So what's the square root of 10?
3.16.
Yeah, so it's going to be 2.6 divided by 3.16. That's it. It's not 0.08, it's what's your decimal place? .6 divided by 3.16 is there you go. Now you got it. Boom. Now you got to do stomates. And you got 3 different groups. Y'all are still working on the P generation. You need to get down to the F1s and F2s as well.
Because for some especially the F1 F2 the same group, consider error, but I also counted only 1 decimal point, so they were different more. But others would not
See, Randy, what room are you in? 6. That's 5. Diego, what room are you in?
I'm in
Your room 1. Okay, I see you're in room 1 with Abel. Caleb, you're room 2. You guys, Ali, you're in room 3. So that's good. I want you guys are in different rooms. I need to know how many minutes do you guys need to finish? Yes, you need to ask. I need to know how many. Yeah, you're in the same room as him. How many more minutes do you guys need? Ali, I need to know how many more minutes do you guys need? 5?
like 5 minutes.
You said like 3 or 4 minutes.
Oh.
Yeah, I got you. Okay, Randy, how many minutes do you guys need?
What's your group say? My phone said that you said 3. 3, 3, 4, 5. Yeah, let me see F1 real quick. Alright.
How many minutes is it, Randy?
I'm trying to figure out because Miriam's been struggling.
Okay.
Poor Miriam.
You guys would, if you talk to her, she'd probably feel a whole lot more comfortable than having to go and look at the chat over and over. Well, that's it, but there's other people in the room. Tell them, say, talk to her. But you've got other group members, is what I'm saying.
Oh,
Did you guys finish?
yes, we did.
Okay, yeah, you're the one room I couldn't get into. There's some other groups that are still struggling. Whose did you guys use?
They use me.
Okay, they used your file. All right, I'm gonna check it out. Thanks.
Stop. Stop. Man, I hate group. Oh, God. On phone. I guess I'll put it back.
Hey, I was just like, hey, I just checked yours, David. It was incomplete. You need to finish it if you're using your document.
And I'm still working on mine.
Okay. All right. Well, share it with everybody so they can see what you're working on at the same time.
Okay, you go ahead and share it then.
Kind of help you. See a doggy, right?
Why is it doing that? Doing that thing where it adds zeros to the decimal.
All you got to do is just go in. You see that under where it says format? There's that tool that says decrease decimal places. Use that to decrease decimal places. I'm glad you guys are using Excel. You'll be so much more comfortable using this after using it. I need you guys to be comfortable with it because you guys are going to use it a lot next year. I use Excel more. I think it's slightly faster, but this is a document you can't lose. You just upload it to the cloud and keep it. And tell her to refresh her screen. Walk in. Since I'll look at my email, grant access. It's really not complicated. It's just getting used to it. That's all. All right, I just gave it to her. She should have access now. She should be green. Just, you've already got one on Sheets. Oh, no. You got a phone for it. All you do is just take the standard deviations divided by the square root of your sample size. So if you got a sample size of 10, you're just taking whatever standard deviation you have divided by 3.16. It's simple. It's really not hard.
I did it. Copy and pasting. Now you can paste it from where? Huh? From where? The answers are on here somewhere.
Yay, David Daniel.
Please.
Knock, knock on the door. Who's it for? There's nobody in here. Look in the mirror. Bro. We're gonna go. Turner's group is still feverishly working. Oh my God, I gotta finish. Oh my God. Okay, here we go. Oh man, so we're back, guys. So it looks like two groups. I was going through and checking. It looks like two of you guys were able to get through all three. I have a question. Do you think natural selection will decrease variation or increase variation? Will natural selection increase variation or decrease variation? Will natural selection increase variation or decrease variation? Thank you, Kim. Thank you, LeVar. Thank you, Manas. Let's see the others. I'm really looking for everybody that's in this room, especially with me. Will natural selection increase variation or decrease variation? Will natural selection increase or decrease variation? Thank you. Thank you, Ali. Thank you, Daniel. Thank you. It's not a trick. Thank you, Randy. Thank you, Keaton. Thank you, George. Thank you, Watson. Thank you, Landry. Thank you, Gavin. Thank you, Santos. All right. I'm still waiting on Diego. I'm still waiting on Abuelito. I'm still waiting on Ali. You did? I don't see you. You said increase? Okay. All right. So Diego, increase or decrease? Abuelito, increase or, huh? And what'd you think, Diego? All right. Okay, so Santos, can you come on and tell me why you chose the answer you chose? Because you're correct. I want to know if your line of reasoning is correct.
Well, I guessed decrease because, like, in an environment.
Could you speak up just a little bit so I can hear you better? I'm sorry.
In an environment, if one like trait is favored over the other, like that one's gonna be more fit. And so like over time, natural selection is gonna get rid of like all the other traits that's not helping the organism be more fit.
You are 100% right. Remember, basically, you are removing individuals from the population that have traits that are not favorable. So under selection, you should not have an increase in variation. In a Hardy-Weinberg equilibrium, yeah, you should have an increase in variation when there's no selection, no sexual selection, no ecological selection, there's mutations. You should increase. But under selection, you should decrease. So let's look and see. This is my P generation. You had an average here. Let's look at my average was 15.5. That should go up if we're selecting for trichomes. I'm sorry, trichomes 4.3. We should have more if we're selecting the ones the top. In this case, the top 10%. So they bred this individual here, and they bred this individual here. No, actually, they bred this one and this one. These were the top two. Actually, what am I thinking? I'm supposed to be looking at trichomes. Yeah, right here and here. They bred these two. These were the two that bred together. And they averaged 4.3. Went to 6.6, but that's not really measuring variation. Standard deviation is measuring variation. Standard error is measuring variation. Variation decrease went from 2.6 to 1.9. And you're going to have to talk about that whenever you guys are in your IAs. We didn't get to do the tidy method. So just to share one more thing, we had a couple of objectives today. We only were able to accomplish one of those objectives. Only objective that we were able to get today was this. We still have to do this. We'll have to do this Thursday. Don't be late. Now there's some questions in the chat. Are we allowed to submit now? I will check these tonight. So everybody has to submit their spreadsheet tonight. It has to be correct. If you need help, you can come in today after I give the retake there is a retake today for convergent and coevolution. That's at 3:15. So I'll be done with that by 3:30. If you need help with this, 3:30. But this is going to be something that does, if you want to submit now, yes. There's a couple people asking you submit now. Yeah, if you finish, go ahead and submit. All right, you guys be good. I will see you after school in office hours.